So let's think of a couple different things that could happen to our budget constraint, things that would change our budget constraint. So two things that would change, I'll just put a delta for change, our budget constraint. So two things that would change our budget constraint would be a change in income or a change in the budget constraint in general. So maybe our budget goes up or down. So for instance, let's say Alex used to have $1,200 to spend on fish and mangoes, and maybe it goes up and he now has $1,600 to spend, or maybe it goes down and he has $800 to spend. So for example, Alex's budget decreases from $1,200 to $800, or it could go up. The other scenario we'll look at that's going to change our budget constraint is a change in the price of or more, or both goods, one good. So for example, maybe the price of fish decreases from $4 to $2. So let's look at both these scenarios and think about how these scenarios would affect our budget constraint. So let's start off with scenario A over here. So let's say this is A. And we're going to concentrate on this 1,200 to 800. So we had mangoes and fish. Hopefully I can have enough colors here so we can differentiate between the two. And if you remember the first thing we had, the first situation where the budget was $1,200 looked like this, where 1,200 was the y-intercept and the x-intercept was 400, or I should say 300, 1,200 divided by 4. And so this blue, the price of fish equals $4, the price of mangoes equals $3, and the budget, hopefully we can read this, equals $1,200. And let's say these prices remained constant, but let's think of what would happen if the budget decreased to $800. But price of fish is still equal to 4, and the price of mangoes, still equals $1. I don't know why I put 3 up there. $1. Sorry about that. Okay, and so let's think of what's happening. So now we can do the exact same thing as we did before, but now if we spend our entire budget on mangoes, we could only afford 400 of them. 800 of them. 800 divided by 1 is 800. And let's say the price of fish now, we used to be able to afford 300 fish when the budget was 1,200, but now the price of fish is still 4, but the budget has gone down to 800, so 800 divided by 4 is 200. So notice that what's happening is this parallel shift in of our budget constraint here. So the slope of this budget constraint isn't changing because the prices are remaining constant. And the slope of this budget constraint has to do with the prices. But what is changing is the intercept. So the whole curve is just shifting in, or the whole budget constraint is shifting in when there's a decrease in income, a parallel shift in. Now if our budget went up, there'd be a parallel shift out, assuming that the prices remain constant. So this is what's happening when we have a decrease in income, this parallel shift in. Now let's look at this second scenario, a change in prices. So this is scenario B, and fish and mangoes, and hopefully my algebra is a little bit better. And again, let's use blue to show the original situation. So 1200, I guess I could have made this a little bit steeper given the numbers. Hopefully that's not too bad for you. So 1200 and 300, a straight line between them. So this was that original situation. Let's say now this pink on this graph is going to represent when the price of fish falls to $2 from $4. So the price of fish has gone down. So to figure out a new budget constraint, we need to think of, okay, the price of mangoes is $1. Our budget is still $1,200. Well, we could still afford 1,200 mangoes if we just purchase mangoes. It's not affecting, if we're just purchasing mangoes, this change in the price of fish doesn't affect anything. But now let's think about what our intercept on this x-axis looks like, where we're catching the number of fish. Well, the price is now $2, and to figure out what this intercept is, we're going to take our whole budget, 1,200, divided by $2 is equal to 600. So now, this is what our budget constraint looks like. And so notice that when the price of fish went down, this whole kind of curve just kinked out because it's changing the slope of the trade-off between these two goods on our budget line. So the budget line here, the slope of it has to do with the price ratio, has to do with the price of fish over the price of mangoes. And here, because the price of fish went down, that's going to change the slope of our budget constraint. Now, if the price of fish went up, instead of kinking out at this point, it's going to kink in a bit more, and the slope's going to be even steeper. So that's two scenarios, two different things that could happen to our budget constraint. We can have a change in the overall budget or overall income, and that's going to have a parallel shift in if the budget goes down and out if the budget goes up, if we're holding prices constant. The other thing that could happen is we could have a change in price, and that's going to change the slope of our budget constraint.